Yay, we're on the thing that I wanted to be on, so I'll move this over a touch. Right, well, let's look at kind of some examples of solving a system of equations using the addition method, also called the elimination method. Right, I'll start with a simple one. I'll do a kind of middle of the road one, and then we'll finish on a hard one. Right, so this would be an example of a simple version of that process. So imagine that you had two equations. The first one was this guy. And the second guy was that. Now these particular equations are written in what's called standard form. Remember, there's only really two ways that these get written. One of them is y equals 4x plus 1, right? Sometimes the equations get written that way. Have you noticed that when they're written that way, you tend to use the substitution method because they're kind of ready to be used? And the other method is when the x's and y's equal a number, which we have in these two. So I'm going to call this equation 1, I'm going to call this equation 2. And the way the addition method works is that if you have the same number of x's or the same number of y's, but one is positive and the other is negative, as we have here, can't you simply just add them together? So you go 2x add 4x, that gets me 6x. And here's the cool part. Won't the plus 3y and the negative 3y, when you add them together, kill each other off? And 12 add 18 gets you 30. And what you've now got is a single equation, just one equation, with one unknown. And they're dead easy to solve, aren't they? Just a matter of divide both sides by, in this case, 6. So I'll divide both sides by 6. And there, I'm halfway done, aren't I? I now know what x is. We still need to find y, don't we? Can anybody remember what you do to find y? How do you get it?
Plug x in.
Yeah. Does it matter if you plug into equation 1 or equation 2?
No.
No, it doesn't. You're right. So put x equals 5 into, that's just my abbreviation for equation. I can't remember which one I picked, 1. So 2x plus 3y is equal to 12. But now we know that x is 10, it becomes 2 lots, x is 5 I should say. It becomes 2 lots of 5 plus 3y equals 12. And that becomes 10 plus 3y equals 12. And then as long as you do it to both sides, it's okay rule. So can't we just subtract 10 from both sides? And I know we probably don't like fractions, but they're not the worst fraction in the world. Would you agree? You just divide both sides by 3 and you get the answer 2/3. And then typically in the homework, isn't there just a box and you just type in that? Now, see when you're doing 2/3, don't go on your keyboard to that symbol 3. There's a little math, I call it a math template over on the right hand side. Do you know that little thing? And you click on it and one of them's a fraction choice. It'll probably look something like that, right? And you plug the 2 in the top and 3 in the bottom, and that way it will accept it. Just a little idiosyncrasy, but you've got to be aware of it. Now that one, I called that one my easy one, because you really didn't need to do much. Wasn't it good to go? You already add them, boom, you're good. In this particular case, it was the y's that disappeared, but aren't you allowed to get rid of the x's in some situations? It may be easier, less work. So here's my, I guess I'll call that example 1. Here's what I'm going to call my kind of in the middle of the road kind of question, right? Not the hardest one, just something a little bit on the average side. So I'm going to put some at the side here. Just try to make it so it comes out good. So that'll be 2, my first equation. And for my second equation, I get that. Now, in this situation here, do you see that we have a problem? It's quite a major problem. I can't add the two equations. If I added them, wouldn't I just get another equation with 6x and 7y equals 4, which means I'm no better off? It's because this particular fella doesn't have the structure that we're looking for. And the structure we're looking for is to have the same number of x's, but 1 plus or 1 negative, or the same number of y's, 1 plus, 1 negative. And once we get to that format, then we can start adding. So I'm going to look at this question. I'm going to think to myself, I could decide to get the x's to work, right? I could decide to fix the equation so the x's work. Or I could fix the equation so the y's would work. And me personally, being a bit lazy, I always want to do the most efficient one, right? The one that has the least amount of work. Do you think it's easier to get rid of the x's, or do you think it's going to be easier to get rid of the y's?
The x's.
I agree with you. When you look at the x's, don't you only need to change the top equation and make it fit this one? Now, if I just multiply by 2, that won't do it, because that'll make it 4x. So it's not uncommon, isn't it, to have to multiply the thing by a negative number, in this case, -2. So I'm going to multiply everybody, including that guy at the end. It's easy to forget to do it to the guy at the end. And I'm going to have -4x, -8y equals -4. And I'm going to call that my new equation 1. And then I'm going to have 4x plus 3y equals -6. And that's going to be my equation 2. And so I'm kind of where I started, right? I'm not that far away from where I was at the beginning. But I do have one. Why is that not me? Oh, yeah, something weird going on here. Forget it. Okay. These two guys can now be added. They kill each other off. -8 add 3 is a bit messy. You get -5y. When you add these two together, you get -10. And don't you just finish with a divide both sides? Right, so divide both sides by -5, you get a +2. And there's one of my answers. And then I'm going to put y equals 2 into that equation, or that equation, or that equation. Doesn't matter, right? They all work. Anybody got a preference? If not, I'll just randomly pick one. You want that one? Yeah, I know I'll pick that one. So what we now have is 2x plus 4 lots of 2 equals 2. That makes 2x plus 8 equals 2. That makes 2x, subtract 8 from both sides, and there you go. So in your little box over here, -3 goes first, because x's always go first, and y is 2 always goes second. And that's probably all you need to write down as far as the, the solution to this question goes. Are we getting a feel for how this process works? It's quite different from the substitution one, where you get y equals 2x plus 1, and then you plug in the law and you do distribute law and all sorts of stuff, right? It's got quite a different kind of structure to it. But it does the job, right? For this system of equations, the only combination that's going to work here is -3 and 2. Now, I said I'd give you 3 versions. So that was, in my boat, that's kind of the average kind of level. So I'm going to give you my third example, which is going to be the horrible one, right? The worst kind of scenario kind of thing. And there's lots of versions of what that might be. I'm just writing down I'm actually writing down the solution first, and then I'm going to create the equations that way I can get nice numbers. Okay, so I'm going to do 2x plus 3y, and I get 10. Now I'm going to do 5x minus 2y. And I get negative 13. Okay, let me just double check that. Negatives. Oh, yep, that's okay. Yeah. Right, now what basically what makes this the worst case scenario, at least as you look at it, can you see that you can't fix it by just multiplying one equation by 2 or 4 or minus 3 or something? Can you see that's not going to do it? There's no normal number. Don't go fractions. It never works, right? Don't try and say, oh, I'll multiply both sides by 17/54 or something. I mean, you're just asking for trouble, right? So only whole numbers count. You can only use whole numbers. That's my rule, right? You know there's no whole number in the world that you can multiply this by that will kill off these. Agreed? Don't matter what you do. If you try and get rid of the x's, 2 won't turn into 5, right? It'll turn into 4x, it'll turn into 6, 8, and 10x, right? Things like that. And won't that 3 just turn into 3, 6, 9, plus and minus 3, 6, 9, right? But it'll never turn into negative 2 or positive 2 for that matter. So what we have to do in this last situation is adapt to what we did in the previous one. And can you remember what we did in the previous one is we multiplied one of the equations by a number. So all I'm going to do is multiply both equations by a number, right? Fix the first and the second. So now I have to figure out which number it is. Well, the best thing to do in a question like this is just decide which letter you want to get rid of, because it really doesn't matter. Both are going to probably take you just as much time as the other, right? So do you want to get rid of the x's or do you want to get rid of the y's? I've got a preference, but that's just me.
X's.
Oh, okay. And I'll do that because that's what you asked. Do you know what my preference was, or why my preference was y's?
Smaller numbers.
Oh, that's another reason I never thought of. Do you notice one is
You already-
positive? Say again?
I was just going to say, because you already had a positive and a negative.
Yeah, that was how my brain is working. But I want to do what you showed just to show you it doesn't matter, right? You can pick all the x's, you can pick all the y's. You know, in some cases it won't matter because they're both equally ugly and they're both going to be equally difficult to do. So now, since we've committed to getting rid of the x's, we have to figure out what to multiply the top equation by, that's the 2x, and what different number to multiply the 5 with. Actually, it's kind of easy to do. Now, do you see those two numbers I'm going to multiply, the top equation by 5 and the second equation by 2? Can you see where those two choices came from? Don't you multiply this guy by 5, and don't you multiply this 5 by 2? The effect is, aren't you going to get 10x out of both equations? Right? 5 times 2, 2 times 5. So once you've decided you're going to get rid of the x's, just look at the opposite number, right? That 2x and that's a 5, just multiply the top one by 5. Say the bottom one's 5, just multiply it by the 2 and that'll work out fine. There's only one last thing I need to decide. Don't I need 1 plus and 1 minus in this case? So which one do you think I should pick? Or do you think it matters?
The 2.
Yeah, okay. So here goes. Everybody, including the 10. I get 10x, I get 15y, I get 50. Everybody in the second equation, by negative 2 here. So that's negative 10x. That turns into positive 4y. And this guy turns into positive 26. So that's going to be my new equation 1 and my new equation 2. Have you seen what we've done here is we've taken a really ugly system of equations and converted it into an equivalent system of equations that are much easier to deal with. Can you see that we're ready to add? You see the x's are going to disappear? So let's add. They kill each other off. 19y is equal to 76. And I hope I did that thing at the back right. 76 when you divide it by 19, yay. It came out nice. So far, so good. Now, aren't we just going to put y equals 4 into any one of these equations we feel like? And that'll get me the missing x. So I'm going to put y equals 4 into, oh, I don't know, equation, that one, probably. 2x plus 3y equals 10. 2x plus 3 lots of 4 equals 10. 2x add 12 equals 10. Subtract 12 from both sides and then divide both sides by 2. And our solution becomes negative 1 comma 4. In this last part, where I used the y equal 4 and substituted it into one of the 4 equations so I could find out who x was, it wasn't actually random that I picked this one. Have you any idea what my thought process about why I thought that was the best equation to use? I mean, all of them would have worked, but why I think, or I thought that one would be the easiest to use.
Because they were all positive and small numbers.
Yes. Me personally, because I'm careless, if negatives are involved, isn't there a vague chance that you might miss it or forget it or put it in the wrong place or just screw up? And when big numbers involved, you try and do too many things in your head, or you try and do them too quickly and you do that. So it's just been my experience that when we come to the final stage, right, I know one of the things and I'm going to find the other. From my experience, it's a good idea to pick the one with the smallest numbers and with most things positive. Right? Sometimes you can't avoid a negative, but if there's one that doesn't have anything negative in it, that's probably going to be my go-to guy. But theoretically, couldn't I have chosen that ugly one there? And it would have worked. You would have got the same answer, we'd have still got that. So it's not a biggie if you don't do that. Okay. Now, to finish this, and then we're going to move on to the application questions, I want to show you again some special cases when you try and use this method. You remember what we did last time? We said, look, when there is a solution, visually what you're doing is you're finding out that unique point where the two lines cross, because that is a line. You know, you can draw that. That is a physical line, and so is that. And they meet at some given point. And that's what we would expect to get from most situations. But don't we know that there is some questions that look like that, where the two lines are parallel, and when that happens, there is no solution. And the other one, which is harder to draw, but couldn't you have identical lines? In which case, when they're identical lines, isn't there an infinite number of solutions? So what will this look like algebraically when these happen, right? So let's look at them. I'll show you very simple examples, because you do the same method that you're doing here. So you're going to, you know, if I did awkward numbers, it would work as well. So let's suppose I had 3x take away 2y is 10, and I had, negative 3x plus 2y is 15. Just imagine we had that. I'm picking a really simple one. Now, these equations are good to go, right? They're ready to be added. If you add these, don't the x's disappear? Oh, wait a minute, and so do the y's. So what you're left with is 0, but the two guys at the end, they don't disappear, right? They combine to get you 25. This situation, when you do the algebra, right, and maybe you have to multiply this equation by 5 and multiply this equation by 2 before this happens. So you might not know it's going to happen until later on, right halfway through the working. But eventually this is going to happen. Which of these two situations is this reflecting?
No solution.
Okay, no solution. And so you are talking about parallel lines, no solution. Now, I'm not quite sure, I guess you'll find out. When you do it, is it a box and you just type in no solution? Has anybody done something that had no solution and that's what you needed to do? Right. So that's what you'll do. You just say no solution and you're good to go. Right. Let's look at identical. Right. Well, suppose you had 3x plus 2y equals 5, and you had 6x plus 4y equals 10. Now I'm going to call this equation 1, I'm going to call this equation 2, and I'm going to solve it in the usual way. Now when you look at this system of equations, wouldn't it be reasonably easy, say, to get rid of the x's, just for argument's sake? Can I turn 3x into negative 6x by simply multiplying equation 1 by what, negative 2? And that gets me negative 6x, negative 4y equals negative 10. And I don't need to, in this particular case, do anything at all to the second equation. But when you add them, the x's disappear, the y's disappear, so that means 0. And the two numbers cancel each other out, and you get another 0. So can you see that when you do it to this particular question, can you see what you now have is 0 equals 0? And that means that there is, in fact, an infinite number of solutions, because these two lines are actually identical. They're the same line, one on top of the other. Okay, how are we going? Are we good with this method, the addition stroke elimination method? Is there any questions about it before we move on to look at the applications, which I think is going to be more challenging? Okay. I just had a thought. Do you want me to give you a couple of questions to try out? Give you 10 minutes to, have a shot at them, or do you feel we're good enough to just to move on? Do you want us to do that? Your chance to vote. Stick your thumbs up if you want 2 more questions that I'll let you do first, and then I'll do them. Okay, democracy wins. So what we're going to do now then is we are going to have a look at the application questions. And if you give me a few moments, I'll have the thing up and running. I'm just finding one. Can you see the homework? You're looking at the homework here? Okay, so the guy we're talking about is 3-6. Do you notice how it goes 3-1, 3-2, and 3-6? It's not that I've missed important stuff out. We haven't. This textbook just does matrices, and we're not any matrices, right? We don't use them, so it's not going to be an issue. And I'm now going to view this fella. And I'm going to, I don't know if you can see that. Can you see the homework questions? No? Okay, that's what I thought. So, let's have a look. Now, this writing might be quite small because I've got a really big monitor, so I can see it pretty easily, but I don't know everyone's in the same boat. Can most of you read this question? You can see it. Okay, it's going to make life a little bit easier. So the first question says, write a system of 2 equations in 2 variables and solve the problem. And then it says, the Pacific Crest Trail runs from the US border to Mexico. Is the Pacific Crest Trail what became the I-5? I don't know. Is it just a totally different road? None of us know. Okay.
The Pacific Crest Trail is a very long hiking trail.
Okay, so it's got nothing to do with the I-5. It just looks like that's the road the I-5 takes, right? Because of the way it goes all down that coast. But okay, that's kind of cool. You should go, if you ever go to Scotland, there's a really cool, if you're into hiking, there's a really cool trek. It's called the West Highland Way.
Yeah, Pacific Crest Trail is like one of those trails that people like train for to do, and it takes like weeks to complete all that stuff.
The West Highland Way is basically the same thing. I've never been on it, so I'm making up a number. But it takes something like 5 days to do it. And it's not particularly long, but you go up and down an awful lot of hills. So it takes you a long time to do it. Anyway, as I get distracted, let's get back into the story then. Now it says the sum of the lengths is 4,824, and the difference between the two is 476. So they give you a whole bump at the start, but basically all I'm going to do, and I'll write this down and then you can see it, is X is going to be the length of, I'm going to call it PCT for Pacific Crest Trail. And I'm going to make Y, my second variable, be the length of the Appalachian Trail. And we're told, I'm just writing down these numbers so you can see where my equations come from, that when you add the two things together, it's 4,824. And when you find the difference of these two, it ends up being 476. So I'm now going to go back in and try and show you how you create a system of equations from that information. This is step one. X is going to be the first thing you're being asked to find, and Y is going to be the second thing you're asked to find. So in these typical questions, they're going to say, find these two things. So they might say, find the cost of a first-class airfare and find the cost of a normal airfare. Find the cost of hamburgers and find the cost of fries, right? Find the distance traveled on the highway, find the distance traveled on the back roads, right? So there are always going to be two things that you're being asked to find. Very often in the puzzle, it's in the last sentence. So they tell you a whole load of stuff at the beginning about the Appalachian Ways and all that good stuff. And then they finish with, find the length of the Pacific Trail and find the length of the Appalachian Trail. So I'm going to make X the first missing thing. I'm going to make Y the second missing thing. So that's step one. So step two is find two pieces of information that you can use to generate two equations. Now, in that original story, they told you that the total of both of these added together gave you a sum of 4,824. So that's a piece of information that's going to allow me to generate an equation, right? And then the difference between these two is 476. Well, isn't the sum X add Y? And isn't that 4,824? Agreed? How will I write down the second piece of information that they gave me that's going to generate an equation? How would the difference being 476 be written in terms of these X's and Y's?
X minus Y equals 476.
You nailed it. Now, once you have got these two equations set up, you can solve them any way you like. Theoretically, you could solve it by graphing. Please don't. I mean, just look at those numbers. It ain't going to work, right? Theoretically, yes. I mean, if the numbers were small, 2 and 4, you could probably do it, right? But even then, I wouldn't do it. So there are really only two methods: substitution, elimination. Both methods work. especially if you know how to make it. You know, sometimes you have to rearrange things to get it to work, but both methods will work. But sometimes, very often, more often than not, the two equations that you've got here kind of lend themselves to one particular method. What do you think would be a good strategy for this one? Substitution or addition?
Addition.
I agree. Can you see why he said that? Aren't they ready to go? And I'm always in favour of making my life easy, which includes calculators when the numbers get big, especially here. So clear, 4824. Then you add the other one, which is 476, and you get 5300. And if you notice, although the numbers are big, they're manageable, aren't they? They're not horrendous. And then to find the x, then, won't you just divide both sides by 2, which is what I'm about to do right now. And then you're going to get 2650, and I'm going to put a kind of little bubble around that. And in the solution thing, they had a kind of thing that looked like this, and they had the PCT one here and the Appalachian Trail here. You type in 2650. I'm not finishing this question. Would you agree that you know how to finish these questions yourself? In fact, in quite a lot of the questions that we're going to do in the applications, I'm only going to set up the equation, and then I might talk about what method, but that's as good as it goes, because you need to get some practice, right, at finishing them off and putting all the pieces together. Are we comfortable about that? Oh, I forgot to put in step 3. Step 3, choose your method. And step 4, solve the problem. So you see it's a 4-stage process. Stage 1, identify who the two things you're being asked to find, the X and the Y. Step 2, look at the story and find 2 pieces of information that you can use to get 2 equations from. And write them down. Step 3, look at your 2 equations and make a decision. Addition method or elimination method. And then step 4, right, do it and get the answer. Any questions about that one? You feel good? It wasn't the worst looking one in the world. They do get worse, but yeah. Let's look at our next fella then. What you're looking at here, oh, I've got an idea. This may or may not work. I'm just trying this out. If it works, great. If it doesn't, then I won't try it again. Can you see the questions and a word processing blank piece of paper? Can you see those 2 things are only one thing? Okay, so I'm going to go and do this. And it might, as I say, it might work. Oops, it might not work. That's fine. If it doesn't work, I'll live with it. Okay, so I get problems. Oh, here it is. The thing I was looking for was hiding. There we go. Now I'm going to try and share screen too. This, as I say, this may or may not work. Are you now looking at, on the left-hand side, the questions, and on the right-hand side, an open Word document? Cool. Right, so I'm going to have to turn this way. What that allows me to do is I can show you the question, I can type the equations, and it'll kind of make it a little bit easier rather than me, you know, it disappearing and then you just seeing a kind of an abbreviated version. So let's look at this picture here. There's a picture where they have an angle here A, an angle here called x plus y, an angle here B, and an angle here called x minus y. And up here they tell you A is 100 and B is 60. Right. So I'm going to say x equals, I don't know really what to call this because they actually give you the thing. So x is going to be the first angle, the one they're calling x, and y is going to be the second angle. So I guess that's me identified the x and the y. Agreed? Now let's look at two equations. This one is so simple, it's probably going to throw you. I know A is 100. That's this angle up here. When you look at the geometry of this shape, shouldn't this angle here be the same as it? Would you agree that this angle, this corner angle, is the same size as this corner angle? Right. So that gives me an equation. Doesn't it tell me that x plus y is going to equal, I tell you what, I'm going to make my life easy here. I'm meant to make my life easy here. X add y equals whatever A is, which is 100. And won't the second angle, which is a little bit harder and you'll have to trust me on it, but you see this little angle here from here to here is called B. Do you know this one over here is the same size as it? So that gives me an x take away a y equals 60. So stage one, identify the two missing ones. In this case, there wasn't really much. X was x and y was y because it's the way the question works. But can you see the two equations come out? Is this one and this one? Right. Choose a method. I know what one I'm picking.
Addition.
Agreed. Want to share why? You're right. What made you decide on addition?
Because the y is already negative and there's a positive one.
Right, so it's pretty much ready to go, isn't it? That would be what one of the ones I called the easy version, right? The easy equations. So I'm not doing this one. Can I just go dot 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 and go through the usual process and you're good to go? So let's move on. The perimeter of a rectangular field is surrounded by 100 meters of fencing. So you can imagine going round the outside of this shape. And the field is partitioned into two pieces by adding an extra little fence in the middle. And when they do that, the total amount of fencing is 117. So you can see there's two different numbers here, which is definitely going to be where I'm going to get my two equations from. But first things first, let's make x equal the length. And I mean the length is the distance from here to here, right? Does that make sense? That would be the length. What are you going to call this side here then? That's going to be y, but what name do you give to this? I want to be consistent.
The width.
They call it the width, right? Do you call it the breadth by any chance? No, okay, that's what we call it in Britain. That's why I didn't want to do it because I couldn't remember whether it was American or British. Sometimes you use words that we use, most of the time. Oh, I just did it, didn't I?
They express in like English nautical stuff still.
Is it? Is that where it comes from?
In like when they talk about like shipbuilding and stuff, sometimes they still use breadth.
Oh, so the word is kind of floating out there, but it's limited use in America, whereas in Britain it would, there's a lot of Americanisms in Britain now. So you go to Britain, people might well use width. You know, some, if you watch enough TV programs, let me pick up American words. Actually, if you watch enough British programs, don't you start picking up British words? Now, it works both directions. Okay, we got our step 1 done. Let's go back to the storyline. The 100 meters they're talking about is the distance round the outside of this field, right? And that ends up being 100 meters in total. Now that does generate an equation. I'll tell you what it's not. It's not x plus y equals 100. Agreed? Because if you call this distance x, don't you also call that top one x? And if you call this distance y, won't you call this side one also y? So could someone just speak out and tell me what the equation for the outside of this field is going to be in x's and y's?
2x and 2y.
Okay. And that's going to equal 100. Great. Okay. Now, the second one's a bit trickier, but it is possible to figure out. If you count all the fencing in this picture, that means the outside, but also this little piece in the middle. Now, remember, this distance is x, and these distances are y's. Can you see that you get a similar looking, but not the same as 2x plus 2y, right? It's not quite the same. It would be 2x, but how many y? If you wanted all the fencing, right? Are you happy about where that 3 came from? Let's show you. Watch my mouse pointer. 1x, 2x's. That's the 2x's. 1y, 2y, 3y, right? The total fences. And that is equal to a little bit more, as you'd expect it to be, 117. So here are our 2 equations. Step 3, choose a method. Looking at that guy, right? Addition or substitution?
Addition.
Okay. Would you agree in this case, you have to change one of the equations, even though it's a minor change, you still have to do it to get it to be ready to go? Would you agree as well that it's the x's that are going to get killed off? What will I multiply the top equation by to make that happen?
-1.
Right, so I'll write it down in English. Multiply by -1. Right, can I dot that? Can you imagine what the rest of the math is going to look like, and you finish it off in your own time? Time for a new equation. Where am I going? The best way to tackle these questions is to have like a little shopping list. I'm calling them step 1, 2, 3, and 4. If you have a kind of shopping list, doesn't it give you a kind of goal? This is what I need to do first. Now I've got that, this is what I need to do next. Now I've got that, this is my 3rd step. Now I got to finish it, boom, we're done, right? So this is a new guy. What makes him new? This one, and I think question 5 also, introduce percentages into the puzzle, right? There's a 6% here, and there's a 10% there, or whatever it might be. So a farmer keeps some animals on a very strict diet. Each animal is to get 12 grams of protein and 8.5 grams of carbohydrate. Are we good so far? Right. Now, I need to figure out step 1. Where do I look for it? Do you notice the last part? How many grams of each mix should be provided? Now the mixtures are called mixture A, right, and mixture B. So X is going to be the amount of mixture A that you use. And Y is going to be the amount of mixture B that you use. So see, when we're finished, it's going to end up being something like, I don't know, use 4 grams of A and 8 grams of B. You know, that's the kind of answer you're going to get, right? So the guy would say, okay, 4 grams per thing, 8 grams per thing, give it a good mix, right? That's what he's getting. Now, the equations is the next phase. If you have mixture A, and let's suppose you have X amount of it, right? X could be 20 grams of it or 2 grams. If you look at this and you say, okay, how much protein do I get? Well, you get protein from the X's, which is how much of this stuff, and you get protein from the Y's, which is how much of that stuff. So this is me using the protein. You're going to get 12%, which is 0.12x. And you're going to get 15% in mixture B. So you're going to get 15%, which is 0.15 of the Y. And that's got to equal 12 grams. Huh. So I'm getting my information from this table. I'm saying 12% of that plus 15% of that should add up to 12. Now 12%, I don't write 12 and I don't write 15. Do you know percentages are also decimals? Do you know 12% is actually 0.12? That's why I'm using that. And so there is my first equation. And I got that by looking at how much protein the story said you needed. Oh, but that protein looks like I've spelt it wrong, but never mind. What about the carbs? A very similar thing is going to happen. Right, you're going to use X as the top one, right, and Y from the bottom one. So you're going to get 0.13X out of this fella. Then you're going to add 0. Oh, let's do a mistake. 5% is not nothing 0.5, is it? What decimal should I use for 5%?
0.5.
Yeah. Now, do you see how easy it is to do that? I could have easily have done that by accident. And that has to equal, according to this fella and this puzzle, that's going to have to equal 8.5. So do you see that that's a much harder question than the previous ones, right? The creating of these questions is quite well hidden, right? You know two things, right? You know 12 and you know 8.5. And you know that my two equations use the 12 and the 8.5. It's how to make it, right? How to put them together. Now, if that wasn't bad enough, actually this question and maybe one of the others that's coming later, I would probably have put these guys last. I'm a great believer in easy questions at the beginning, average questions in the middle, and keep the hard ones to the end, right? You know, textbooks should do that. They don't always do that. Right, back to this fella. Addition or substitution? Well, let me rewind that. I'm not going to even worry about that right now. And the reason I'm not going to worry about that right now is there's no way in the world I'm going to keep those numbers. Can you imagine just how messy that is going to be to do anything to, whether it's the elimination method I decide or whether it's the substitution method I decide? Would you agree that 0.1 this and 8.5 that is just not going to, it's not going to end well? So I'm going to do a little trick which I like to do, especially when fractions or decimals are involved. Couldn't I multiply everybody in that top equation by 100? Now, if I did this, that guy would just simply turn into 12. This guy would turn into 15. And this guy would just get a couple of zeros added. And this one would turn into 13. And this one would turn into 5. And this guy here would actually just be 850. Are you happy about what I did, or maybe why I did what I did? Are you comfortable why I chose that as a good way to look at it? Now, when I look at these two equations, now I have to decide which method to use. Addition method or substitution method? What do you think?
Addition?
Do you need to change one of the equations? Great. Which one would you need to change here? What would be the easiest one to change?
Carbs?
Okay, so multiply by what, -3? I'll just do this one more line and then I'm going to leave it at that point. This guy here, if you multiply him by -3, becomes -39. This is the good part. You multiply that number, the 5y, and you now get -15y. And then you play about with the 850. And it's not easy to do by -3, but I'll try it in my head. 850 by -3, 240, 2550, I think it is. And it's negative. Can you trust me that they add up and eventually it comes out as nice numbers? Doesn't look like it will, but it will. You okay with that? No. Question 5. A retired couple invest part of their 11,000 at 6% and the rest at 7.5%. Find their annual income for these investments, or they found that their annual income is 741. How much of each did they invest? Well, I'm going to call X the amount they invested at 6%. Oh, where's the percentage point? I know you're there somewhere. There you go. Copy. And then I'm going to do the amount that they invested at 7.5%. Okay, that's step 1. I'm not going to go much further on this one. Let's do the 2 equations, right? There is 2 pieces of information in that story that allows me to generate the 2 equations in the x's and y's that I need, right? Let's use this piece of information. It's sometimes overlooked. I guess it's because the word part. But if you think about it, don't they only have 11,000 to invest in total? Part of it goes one way and the other part goes the other way. So if you think about that, doesn't that mean x plus y equals 11,000? Equation 1. Now, although this has percentages, you see it has a different structure than the last one. The last one had percentages everywhere. This one has a nice start, right? X plus y is 11,000. It's going to have a messy finish. If you put X dollars and you get 6%, as a decimal, don't you get 0.06x, right? Isn't that 6% as a decimal, right? 6% of X, 0.06 of X. If you then add up the money that they get for 7.5%, you get that guy. And that is going to equal $741. Agreed? Now, I would definitely fix equation 2 by my usual trick. You end up with really big numbers, but at least you don't have decimals. You could decide not to if you chose to and just work with the numbers you've got. Do you think this question is going to be easy to do with the addition method, or do you think I might be able to do a substitution method in this one?
A substitution could work if you rearranged the first one.
I agree with you. And if you rearranged it, wouldn't one possible rearrangement just be that guy? And go and solve it, and you've got it. Right, a little checkup here. You know the book tells you that you're wrong when you're wrong, but it's nice if you know how to check on your own. To me, there's like two major checks. The first one is common sense. And what I mean by common sense is, when I look at the numbers, does that seem realistic, right? So, do you know how they had the Appalachian Way and the other one? Suppose I ended up with one of them was 500 miles and the other was 10,000 miles. Well, I'd look at that map and say, that doesn't look realistic. I've probably screwed up. And then I go and check my working, right? That's the first one. The second way of checking is, once you believe you found the x is 40 and the y is 50, right? Once you've got a solution, can't you just go back to all your equations and plug in the x and plug in the y and see if they really do work, right? A bit cumbersome, it's a bit boring, but you can do it that way. So, common sense, do these numbers look sensible? That's your first one. And that's relatively easy to do because, you know, your brain will tell you, yeah, that looks reasonable or not. So we're about to do this one. See if I end up getting an answer like $10,900 goes to the first bank account and $100 go to the second. I'd be quite suspicious. You know, that seems to be a disproportionate sharing. If I got the answer into the first bank, the 6%, you put $12,000, and into the second bank, you put negative $1,000, I'm definitely wrong. Can you see in that case, negative numbers are totally stupid, right? So that would be the common sense check. Okay, let's move on. Oh, we got a time issue. Darn it. Okay, I get time because I want to move on after this. I just looked at my watch and I think we need a break because there's only so much we can ever take in. So there's only one more question left that I want to do time-wise. So we've got 7, which is this one about somebody doing a snowmobile. We've got this person here doing gummy and jelly beans. And this last question, we've got somebody pouring liquids into a bowl. It looks like some chemistry experiment. So that's questions 7, 8, and 9. So which one do you want to be the last one?
9.
I think I heard 9. Did I hear 9? Are we willing to accept that? And you've got the building blocks of how to do it, right? So in a way, it's probably a good idea that you have at least a couple of questions where you've given nothing, right? You got to do it all from scratch. Because I've been quite good at, you know, giving you a lot of head start on this story. So let's clear the whiteboard again and do x equals. And let's see what we have. How many ounces of the 2 alcohol solutions must be mixed to obtain 100 ounces of 12.2% solution? And it's quite visual, but the boxes tell us, isn't X going to be how much of the 8% solution I'm going to use, and Y is going to be how much of the 15% solution I'm going to use? You agree? In fact, when you look at the questions, can you tell X is going to be gummy bears and Y is going to be jelly beans, right? So here goes. So X is the amount of 8% we use. And y is going to be equal to the amount of 15% solution we use. Okay, so that's step one. Right. So that should become pretty obvious now, right? We've done enough step ones. Let's look at step two. It's a little bit different, but the numbers are here and here. Let's take the first part. How many ounces of the two solutions need to be mixed to obtain 100 ounces? That's an equation, isn't it? Something with x's and y's is going to add up to be 100. X is how much of the first stuff, y is how much of the second stuff. What kind of equation does that get me?
0.08x plus 0.15y equals 100.
Oh, I see what you've done there. That's part of the second answer, but it's not part of this one. I can see, I get your idea, right? 0.8 and your 15, that's going to come in, but not right now. Because we're talking about a total of 100 ounces. Anybody? You just said it, Murray. You want to say it for the rest of us? Oh, I can't hear you. You have to hit the space bar.
X plus y equals 100.
Wow, you did that without moving your lips. Well done. X plus y equals 100. Does that make sense? You see what I'm getting at, right? And Murray, you were saying it, so you figured that out, right? So we are good. Now, see that decimal stuff that we were talking about a moment ago, and I said that that's going to come, but not right now. It's now right now. It's now going to happen. I want 12.2% of solution, and there's a kicker in the tail here. 8% of the first stuff. Oops, don't know what happened there. 8% of the first stuff plus 15% of the second stuff is going to equal something. Oh, darn it in space. It's going to equal 12.2%. Well, that's not 12.2%. It's actually 12.2% of 100. Now, in this case, annoyingly, isn't 12.2% of 100 12.2, right? But I want you not to think that's the case, because imagine it was only 50 grams of the stuff, right? Wouldn't it be 12.2% of 50? And that would be the number that I would write down. So bear that in mind, that it could have been, because see these red numbers that you see here and here, and looks like there's some here and here, that typically means that this question randomizes them. So your homework question won't necessarily have 100 or 12.2, which is why I'm not too bothered about doing some of these questions, because see, when you go back and do the same question, they'll have changed the numbers on you. So you're still kind of going to have to do the question from scratch anyway. Right. So in this case, we get 12.2. I would probably get rid of the decimals, you know, that's my thing. Would you agree this one is probably going to be very similar to the previous question? It's probably going to be a substitution method. Right. And what I would do here is I take that top equation and I'd rearrange it and call it y equals 100 take away x. I don't know where that extra letter came from. And you'll get, I don't know what you'll get 80 of this and 20 of that, you know, get something like this. And we are done. Quite different from what we've previously done. So we're going to look at, oh God, I think it's called chapter 6S, yes. So it's chapter 6, And we're going to be looking at rational expressions. Pardon me. So, let's get started. What is a rational expression? Well, do you know the word rational is just a very, very old word for a fraction? So you could really call this a fractional expression. And that is any algebraic expression, things with x's and y's in them, and there are fractions involved. And so that would be called a rational expression. So we are going to find out today, hopefully, we'll see how the time goes. First thing we're going to find out is how to simplify a rational expression. Second thing is how to multiply them. And the third thing is how to divide them. So, quite a lot, okay. Let's give you an example of a rational expression and some of the things that you have to be aware of. That is an example of a rational expression. Think of fractions. That's what it is. X squared plus 4 over x plus 4. It's a fraction. It's a rational expression. Sometimes you look at a rational expression and you're asked to find the value or the values, because there might be more, of x that make your expression undefined. So we haven't quite got to simplifying it, but we are going to be short. This fraction, you can plug in any value of x you like and you will get an answer. Probably most of the time the answer will itself be a fraction, right? You plug in 2 and you get 8/6, which turns into 4/3, for instance, right? But there is a bogeyman. There is a value of x that you really don't want to try and evaluate this expression with. And the reason you don't want to use this value of x is, don't you have a problem with fractions where the denominator is 0? If I said to you, what is the value of 7 over 0? You should say undefined. That's basically saying you can't do it, right? You can't take 7 and divide it by 0. You don't get any sensible answer. It's okay, isn't it, to have a 0 on the top and a 7 on the bottom? You agree? Wouldn't they all be 0 in that case? And just for fun and giggles, here's one to make your heart hurt. I don't think you've ever seen this before. What do you think we do if for some reason the top is 0 and the bottom is 0? Because I guess that could happen. In fact, I know it can. Do you think the answer is 1? Is the answer 0? Or is it undefined? Because it's only one of those 3 choices. What do you think that is equal to? And it's a guess, I know, because you've probably never seen it before. But what's your gut feeling about what it might be?
Undefined.
Yes. And what that is telling us is that 0 on the bottom is the most important thing. I don't care what you put in the top, you're never going to fix 0 on the bottom, right? Now, how do you simplify fractions or rational expressions? Well, here is an example. If you want to simplify any rational expression, then what you have to do is the following. Step 1. Factor the numerator and the denominator. I can't even spell, can I? No. Yeah. There, got it at the same time. Americans are very nice to me. See if I misspell something, I just say that's how we spell it in Scotland and you let it go. I just can't spell sometimes, I guess. Right, now, that is going to bring a skill that you had in 94, right? Something you practiced. So you should have had practice at factoring quadratics and trinomials and common factors and lots of different situations. If you're a bit rusty on that, you can certainly go online and look up videos and you know, just get up to speed on it. Actually, I think I'll put the thing down here. Okay. Do you recognize x squared minus 4 as what we call a difference of two squares? And what that gets you when you factor it is an x plus 2 and an x minus 2. Agreed? Now, x squared plus x minus 2 is sometimes called a quadratic. It's also sometimes called a trinomial. There is a kind of method for factoring these, depends who you get taught by. In this particular case, only because it starts with an x squared, don't you say, I look for two numbers that multiply together that give me -2, and when I add those two numbers, I get +1. Agreed? Two numbers that multiply together that give me -2, but when I add them, I get the +1. So I am looking at a positive and a negative number, right? And which one goes here and which number goes here? What goes here?
+2 and -1.
Yeah. Now, you might have to do some trial and error. See if you think it's that. Can't you foil that out and check? And if it works, you know you got the right one. Remember F, first, outer, inner, last. So what do you do is your second step. You cancel like terms, or I guess I should call them like factors. And I'm saying this little bit here, 1 for 1, which means one guy gets rid of one guy. So here goes. Can you see that x plus 2 is allowed to cancel out that x plus 2? And that gets us our answer. Now, what some people do, and they're not allowed to because it doesn't work, is isn't there a temptation to cancel this x with that x? And just leave behind some numbers. That is not allowed. You are not allowed to cancel, add or subtract. You can only cancel factors. That's things times other things. These are called factors when you have two things multiplied. Each is called a factor. Okay, let's look at this one. Okay. I have x squared minus 3x on the top, and I have another one of those quadratics on the bottom. Right, let's focus on the top. In this case, it's not a difference of two squares, and it doesn't have three terms, so it's not a trinomial. Try like in tricycle, three wheels, right? It's a common factor situation, right? So what is the common factor from x squared and negative 3x. What's the common factor in these two terms?
The x.
Okay. And when you pull out that common factor, do you see you get that? Are you happy about what it looks like? Now let's look at the bottom. Oh, we got another trinomial. So two numbers that multiply together that give me negative 6. So that guarantees one of them is positive and the other is negative. So that'll be things like plus 6 and negative 1 and plus 3 and negative 2, right? Combinations like that. And we are looking for the combination that when you add these same two numbers together, you get negative 1. So I'm looking for combinations of negative 6. I'll just write some of them down randomly. Negative 1 plus 6 plus 1 negative 6 plus 2 negative 3 negative 2 plus 3. I think that's actually all the ones, isn't it? I can't think of any others. These are the only 4 guys it could be. So which one of these 4 generates that negative x in the middle?
2 and negative 3.
You all agree? So plus 2 and negative 3. So that's step 1 done. You see step 1? Factor everything in sight. Now, step 2. Cancel. Would you agree that this x minus 3 can cancel with this x minus 3? And what's left is your simplified rational expression. And you have to know when to stop. Stop. Don't do any more, you can't. You're not allowed to. Are the cobwebs going a little bit? Are you beginning to get into factoring mode? Because I can tell you right now, that's what you're going to be doing an awful lot of over this set of questions and the beginning of next week probably as well. So let's try another one. Let's just try x cubed plus x over x squared plus 1. I need to factor. X cubed plus x. A common factor? A common factor of x. That leaves me with x squared plus 1. X squared plus 1 is not a difference of 2 squares. X squared minus 1 is, right? But x squared plus 1 has the rather annoying, or whatever you want to call it, feature that you can't do anything to it. So you just write it down again. And the only reason I put brackets around it is to try and emphasize what's about to happen next. Do you see that we can still get some cancelling? In this case, won't this fella cancel out with this fella? Now we have to deal with, and this is going to happen. Technically speaking, if you cancel out something, do you know you're leaving an invisible 1 behind? Most of the time we don't bother about it. So on the top, x times 1 gets me x. But on the bottom, I kind of need it. Because x over 1 is 3/4 of the way to being finished. In this particular case, do you see how the answer ends up just being x? It isn't even a fraction at the end. There we go. Now, I'm going to do almost the exact question again. Do you notice I've just turned the fraction upside down? It's called its reciprocal. Right, so I put that in the top and that in the bottom, right? Now, you can't do anything about x squared plus 1. You can pull out an x, and that gets you an x squared plus 1. Now, I'll cancel this guy, and I'll cancel this guy. 1 is left on the top, x is on the bottom. Do you see those invisible 1s that we don't typically write down? Why, in this particular case, it's important that we do. because the answer in this case is not x, it's 1 over x. It truly is a fraction. And up here it is x, because x over 1 is just x. Okay. I'm going to give you 3 questions to have a little try out, right? Try and get as many as you can. I'll just give you a few minutes. And here's our first one. I'm going to introduce things we haven't done. So you're going to have to maybe think through things you haven't seen. This is going to be x cubed, take away x. And the bottom guy is going to be x squared plus 2x plus 1. So that's a really yucky one I've just given you. Oh, let's change letter of the alphabet. You can't just always get x's, right? Let's do some other letter just to be different. How about a squared plus 5a and a cubed plus 5a squared? That'll be my second one for you to try out. And the third one, is that one. Let me just warn you. Question 3 is a tricky question.
You said question 3 was what?
A trick question. There's something weird about question 3 that you won't like the answer. Let me put it that way. I already got one smile I can see, so that may be that she's already discovered what the problem was. Yeah, we go. Yalla! Come on. There you go. Okay, that was my dog paying me a quick visit. Right, let's get this show on the road. I guess the theme here is factor, factor, factor. What about x cubed minus x? Anything you can take in as a factor there? What about x cubed minus x? Anything that you can factor it? Give me a suggestion. I guess that means you didn't do the question, which is a bit sad. Or you don't want to tell me what you can do. Is there anything you can do to x cubed minus x?
Take out one of the x's, factor out one of the x's.
Great. Would you agree that the bottom is a trinomial or quadratic? It's quite an interesting one because there's not really that many choices. Agreed? Now, superficially, you will look at that and think, oh, you can't actually simplify it at all. But that's not, strictly speaking, true. Sometimes when you factor a thing, you realize that you can factor it some more. Do you recognize x squared minus 1? Recognize that? Isn't that a difference of 2 squares? X squared minus 1 is a difference of 2 squares. That means we can now cancel those two guys out. And our final answer, I guess I'll have to squeeze it down here, looks like that. And you can't do any more to that, so leave it alone. Okay, let's look at question 2, because I put something weird in question 2. Would you agree that the top one has a common factor and that that common factor is a, and when you take that out you get a plus 5? What's the common factor you use on the bottom term, a cubed plus 5a squared?
A squared.
And when you take out a squared, aren't you also left with a plus 5? Now let's see how this one cancels. There's a 1-for-1 cancel. That a does not destroy all of the a squared. Doesn't that a in the top only kill off one of the a squareds? So when I cancel this out, do you see that I'm going to be left with that, you know, that little one that we never worry about until it's necessary. So 1 on the top and a on the bottom. So that's what that one simplifies down to. Now I said you won't like 3, but at least it's going to be quick. X squared minus 9 is a difference of 2 squares. Isn't the trinomial on the bottom? Two numbers that multiply together give you negative 10, but when you add them, you get negative 9. So I know that one of them is positive and one of them is negative. Agreed? And the negative goes here and the positive goes here. And what makes that annoying? Nothing cancels. So basically, we're finished. Okay, now, before I move on to the next part of the puzzle, and then we'll have a look at some of the questions in the homework, is there's still some factoring that I haven't introduced yet. So I'm just going to focus on the factoring part, right? Not the cancelling part, right? So we're going to look at how do you factor this expression? How do you factor that one, right? Because there's lots of different kinds of factors. Looks like your dog's trying to get your attention there, Mark. So these are just put down for completeness sake, right? So you can choose to write this down or not. You might not. Things to look for. Common factors. There is a common factor of 3 and a common factor of x, and that leaves me with x plus 2. Right, that would be how you would do that one. There's a difference of 2 squares. They typically look like that. There'll be x squared or a squared or b squared, I guess, it could have different letters. But isn't it always x squared? Take away a number. And the number that you take away tends to be things like 16 and 25, numbers that you can break into 2 equal parts easily. And we call that a difference of 2 squares, and we get that. We've already used both of those today, right? I'm going to call this one a trinomial. It's also called a quadratic, but this is going to be the simple ones. So this is going to be x squared plus 10x. I'm trying to think of something that would work here. Plus 16. Now, when you get a trinomial and it's an x squared, we call them simple trinomials, because in these questions, you can get a technique. You look at this number and you find all the different ways you can find two numbers that give you 16. So for instance, I could have positive 16 and positive 1. I could have had positive 8 and positive 2. And I could also have positive 4 and positive 4. Right. Technically speaking, can I also have two bunches of negatives? So altogether, there are 6 possible combinations, but the only one of these 6, and there's always only one that's going to work. Don't I look for the combination that gives me 10 when you add them? Those two get you 17x when you add them. Those two there get you 10x, and that is us done. Every single one of them we've done somewhere over here, right? We've at least seen it once. But here's the last one. You can factor a quadratic, a trinomial. The point that makes these complicated, that's why they're complex ones, is do you see that it's no longer x squared? It is 2x squared, 3x squared, 5x squared, right? That makes these much harder to do than the top one, because in the top one you just find all the numbers that you can think of multiplied together that give you 16, and then just pick the one that adds up to 10 and you're done. You cannot do it here. You can't say, oh, I'm just going to look for all the numbers that multiply together and give me 5 and add up to -7. It's not going to happen anyway because the technique doesn't work. This technique, or how you factor them, really is quite varied. I just do the trial and guess, right? You just basically guess and check them out. I've seen people do funny little cross tables. There are all sorts of weird, not weird's probably the wrong word, but all sorts of unusual strategies that you might look online and see. Does anybody want to tell me, not the answer to this, but how the method that they typically use to do these kind of questions? No one willing to share?
I do the 8 times C.
Oh, okay. So that's a strategy where A is the 2 and C is the 5, and you work on it that way. That works perfectly fine. Does anybody do the cross one? If you don't know what I mean, then you don't do the cross one. I'm just going to do the trial and error. It is definitely not the most efficient technique, but it has one advantage. Eventually, it's going to work. So let's start off. Because this is 2x squared, aren't we guaranteed a 2x and an x? Because that's really the only way you're going to get x squared, right, or 2x squared. And now I focus on 5. I'm going to be putting numbers here and here. Because this is 5, these two numbers here and here still multiply together and give me 5. So that doesn't give me very many choices. In fact, isn't that the only 4 ways that you can get positive 5? There's 2 ways of doing it when you make them 1 and 5, and there's 2 ways that you do it when you make them -1 and -5. Now you might say, why did you switch the order? You never did it here. You don't need to switch the order here because it doesn't matter which way you do it, it'll work both ways. But in this case, you do have to be careful about the switch order. Do you see how one of them's got a 2x and the other has only got a 1x? Great. Now, out of those 4 methods, I know that the combined effect is -7. For that reason, I'm going to kill these 2 and not even bother to check them. Why? Why am I kicking out the +1s and the +5s?
Because you need a negative number.
Yeah, I need a negative number. Would you agree +1 and +5 and plus this and plus that? Two pluses are never going to work, right, in this case. So that tells me two negatives. Okay, I've got two choices. 1 and 5, 5 and 1. Which one works? 1 and 5, 5 and 1.
5 and 1.
Correct. Suppose you don't know. This is why it's kind of guess and check. You pick one and you check it. And if it works, you got the answer. And if it doesn't work, the other one works. Well, let me check this one just to prove that it works. It's been a while since you've done this. If, FOIL, right? The first times the first, 2x times x gets me the 2x squared. Check. The outer means the two outside ones, that's the 2x and the -1, gets me -2x. The guy they call the inner are the two inside ones, and they multiply together give me -5x. And then the last are the numbers at the end. So -5 times -2 gets me +5. Can you see? Check, check. Is this coming back to you? Is this factoring stuff that you're beginning to, oh yeah, we did tons of those things. Hopefully you have. Right. Well, what I want to do now is I'm going to go into WebAssign and we're going to see if we can come up with some homework questions and just look and see how the book does the questions, because sometimes that's half the battle, just figuring out how they phrase it. So I'm not doing the review because the review just covers the stuff that's up here. So here we go. I'll hit view. That scratching is my dog trying to tell me something that I know that it wants to go walkies. She gets really unhappy when you don't pay attention to her. So you might not hear her, but she's whimpering outside my door right now, making me feel really guilty. But she'll just have to learn. And she's very funny. Do you know my wife could take her a walk? And she would. And see, after my wife takes her a walk and brings her into the house, she'll still come to the door and scratch because I have to take her for a walk. Right? She's very possessive. Okay, are you looking at the homework now, or will I have to go back out and in? Right, so let's have a look at some of these questions. There's quite a lot of them, but they're all relatively quick, right? Most of them are. Right, this is the quotient of two polynomials, which is just another way of saying this is a rational thing, right? It's called an, or a, rational expression. That's how easy that homework question was, right? Now, fill in the blanks. In this rational expression here, the x plus 8 is a common, what word out of that list is x plus 8? I've already used the term a few times. I don't know if I would phrase it that way. It's a factor.
Factor.
Right? Yeah, bang on. So I'm doing these ones because these are so easy you would do them anyway, but just to get them out of the way. Now, because of the division by 0, the expression 4 over 0 is? Missing word?
Undefined.
Yep. Right, now do you notice that we're already at question 5 and we probably could have done all of them in a minute? Right, so far so good. They're going to slow down. Now this one is something I haven't done. X take away 15 and 15 take away X are called negatives or opposites. Have you ever heard the term opposites? No. Okay. Now let's forget some more of the fill-in blanks. Right. Here is a whole load of pictures, and here is a whole load of who are you. Now, I don't know how much graphing you've done and when you've done it and how good you are at your graphing calculator, but let's put in a couple of these guys. F of x equals x. Well, f of x equals x, isn't it that straight line there? So that one is picture 5. Do you see how that's going to work out? Let's just pick one at random then. Do you see this horizontal line up here? Right, number 3. Which one of these fellas is number 3?
B.
The good news is, see, by the time you get to E, aren't you okay with the last one? It's whatever's left. Oh, I just thought of one. See this fella here? Isn't that the absolute value thing? So that would be this one here. Now, here are, I kind of like this question. It's not a great question. It's kind of warm up to the good stuff. It's still not got to the point where we've got to. Do you know if you stick a -8 here and you stick a -8 there, and they're asking, is this answer equivalent to saying this? Now, do you see they've put the -8 on the top and then they put it directly on the side here? And the answer is yes, it is. What they're getting at here is, do you know that there could be more than one way to write the same thing? And so as long as it's equivalent, you're correct. Right, let's look at this fella. The bottom's the same, so I'm not even going to look at the bottom. Is -8 add 6 the same thing as the negative of x take away 6? I see a nod. I agree with you, so you'd say yes. Is it okay to take the two guys in the bottom and switch who goes first and who goes second as long as you don't change anything else? Is that equivalent? Is this guy the same thing essentially as this thing? Yes. Right, if you stick a negative here or you don't have a negative here, is this the same as that? Correct. No, it's not. That's a contradiction, but no, it's not. Just reminds me when we go driving, my wife likes to drive. She hates me to drive. When we're in the same car, she always drives. And she says I drive too slow and I spend far too much attention looking at, oh, did you see that rabbit over there, when I should be watching the road, and it freaks her out. Anyway, when we do instructions about driving instructions, you can't use the word right. Because if you're in a town and you're looking at, you know, your little thing and you're trying to tell her where to go, she might say, do I go second on the left? And you say, right. Do you see that's a mixed message? I should say yes or no, okay, or correct or wrong. So that just came to me. And I've just noticed a bunch of questions that we haven't even dealt with yet. And I'm going to pause for a minute and go back out. Do you know, I didn't even think about that. We have some fraction expressions of a very simple kind. Do you see that they're full of A's and B's with different powers? So I'm going to wind back a minute. Once that's done, you can see that we're now at the questions that we have been doing, right? The ones that we've been doing a few minutes ago, right? These guys here. That's like the ones we've done. But let me return and show you how to do some of those other ones that I haven't covered. I didn't even realize I had them there. That's my fault. Suppose you had 6a squared over 4a cubed. Right, I could You are allowed to simplify. I don't need to factor any of these, which in a way makes life really easy. I just need to go straight into cancelling. And there's a 1-for-1 deal. I've seen some textbooks, and it might help you, I don't know if it does, but you write 6a squared is 6 times a times a, and you write 4a cubed is 4 times a times a times a. Now, this may or may not help you, but for some people it does. Can you see that I can cancel 1-for-1 and 1-for-1? Do you see there's still an a left in the bottom? And I am going to write this down, although I'm not finished. Can't you cancel numbers? Simplify numbers. In this case, won't you divide the top and bottom by 2? And so the complete finished answer has to be that one. If you type into the software that one, do you know it's going to tell you that you're wrong? Well, you're like 90% right, but you're still a little bit wrong, and that's why it won't accept it. So, you know, occasionally that will happen, that you do all the hard work and then you forget, oh, there's a 2 in the top and a 4 in the bottom. I could have done a little bit more, right? Suppose we mix and match the combinations. Let's do that one. We'll focus on the numbers first. Can I cancel the 6 and the 12 in any way? Is there a number that divides 6 and 12? Yeah. Would you agree that the best number is 6? And that's what you get. I have an a squared in the top and I have an a in the bottom. I could write them down this way, but let's see if we can do it a quicker way. Won't an a squared and an a partially cancel out? But won't there be an a left over? And won't the a be on the top? Does that make sense? That when this a squared cancels out that a, you're still going to be left with 1a. What about a b cubed cancelling out a b cubed? Won't that be quite disastrous? Because that means totally gone. On the top, I've got a 1, an a, and I guess another 1. But really, isn't that just a? And on the bottom, I've got a 2, a 1, and a 1. But isn't that really just a 2? This guy is correct. And you put them into the box and they will give you. Isn't this guy also that guy? A over 2. It's a bit like taking a and dividing it by 2, which is the same as finding half of it. Okay, one more, and then we can return to the questions. I don't know what I've got to do here. 24, 15. Yeah. $24 and 15. There's something out there that you can use. What can you divide 24 and 15 by?
3.
Okay, so that gets you 8, and that gets you 5. That's a good start. So I've got an a in the top and an a squared in the bottom. Can I cancel these out and leave an a in the bottom? A on the bottom. I have a b cubed cancelling with a b. What's going to be left after that? B cubed in the top, cancelling with a single b on the bottom. What's going to be left on the top?
Squared.
Now we're finished. We feel comfortable with that? Okay. Now, there's another example that I've just thought of that they might have put, because since I missed them, they might do this as well. Do you know if you have two guys that are opposites of each other? X minus 7 is the opposite of 7 minus x. They're both being subtracted, right? But the order is different. They are not identical, right? If you plug in 8 here, you get 1. If If you plug an 8 here, you get -1, right? They're almost identical. And you are allowed to cancel them. But if it was x add 7 and 7 add x, if it was that, wouldn't you just cancel them and leave 1 behind? But when things are opposites, when you cancel them, you don't just get a 1 behind. Do you know what you do get left behind?
A 0?
No, a -1. There's still a 1 here and there's still a 1 here, but one of them's the opposite of the other. So you get a -1 over 1, which is -1. I'll try it out. I'll prove it to you. I'll try and prove it to you. Right. I'm saying that that guy is -1, right? Give me any number in the universe, but don't give me 7. That's a bad choice. Any other number you like.
$20.
Okay. 20 take away 7. 7 take away 20. 20 take away 7 is 13. 7 take away 20 is -13. Simplifies down. -1. Have I convinced you that you get -1 when they two cancel? So what that is saying is, see when you do that factor and cancel, let's pretend that we did a really, really ugly one. So let's pretend it's already been factored. Really big, ugly one, right? Right, ends up looking something like that, right? Won't the x plus 3 cancel with the x plus 3 but leave behind a 1? Won't the x minus 7, it's allowed to cancel the 7 minus x, but what will it leave behind? Not a 1, a -1. So what does that make my answer? It makes my answer x plus 1 on the top, -1 on the bottom, which I would probably just call that guy. So, just in case that happens, right? Just in case we end up having to deal with opposites cancelling. And when opposites cancel, which they're allowed to do, will you remember that the answer is going to be a negative answer? Any questions? A lot to take in today, aren't we? You still with me? Hanging in? We need a joke, don't we? Okay. Has anybody got a really bad joke for me? Not one of you have got a bad joke. Michael, you look the kind of guy that has a bad joke. Do you have a corny joke?
Fresh out. Sorry.
Okay. Are any of you intending to become engineers? Good, because I can now insult engineers. So, an engineer dies and he goes to heaven. And he arrives at the pearly gate, and St. Peter's there with a book with the people that are allowed in, and he gives his name and he looks down the list and he can't find it. And St. Peter says, "What did you do?" And he says, "Oh, I was an engineer." He says, "Oh, that's okay. I've got a book where we keep all the engineers' names." And he goes over and brings out his second book and he scans down it and says, "Your name's not here." And the engineer looks at him and says, "Well, what's going to happen then?" He says, "Well, if your name's not in the book, you don't get into heaven and you have to go to hell." And he kind of shrugs his shoulders and says, "Oh, I guess that's where I'm going to end up." And well, he gets down to hell, and you can imagine it's a heck of a place. It stinks, it's dark, it's too warm, it's dirty, it's smelly, it's got everything wrong with it, garbage everywhere, right? That place is a mess. And he's an engineer, and you know, he's thinking, I'm going to be here for eternity. I might as well do some stuff. So he starts, you know, making stuff. And he makes air conditioning system, and he puts it all through hell. Get the funny little robots that go around and clean things, makes lots of them. Air purification takes away the stink. And he does tons of stuff, fixes the lights so they all work. So by the time he's kind of been there a while, hell looks like a 5-star hotel. And God is down visiting, and he's walking around with the devil, and he's looking at all this, and he's saying, wow, that's a big change. And the devil says, yeah, it's brilliant. And then God thinks for a minute and says, did you get an engineer? And the devil says, yeah, it's the first one we've ever got. And God says, you're not meant to get engineers. Heaven gets all the engineers. You don't get them. They belong to us. We get the engineers. And there's a big argument about God says, I want my engineer back. And the devil says, no way, we're keeping him. And at the end, God said, look, if we don't get our engineer back, I'm going to sue you. And the devil looks at him and said, yeah, like you've got any lawyers. Let it sink in. No? Okay. I think if my jokes are really bad, they have the advantage of making you want me to start doing the work again, just so I won't tell you anymore. Did you like that one? Okay. One last very quick one, because the way my brain works, if a joke comes into my head, I just have to tell you or else it distracts the heck out of me. So here's my second joke, very quick. How do you tell an extrovert engineer? So how do you tell when an engineer is an extrovert? You don't know? He looks at your shoes when he's talking to you.
Why are all of your jokes about engineers?
Only today. I mean, what was my theme last time? What was my jokes about last time? It's normally about Scots people and people dying, isn't it? Okay, now you've said that, you've actually said that was my last one. It's not. This is not my last one, because another joke has just come into my head, and if I don't get rid of it, I'll just end up making mistakes as my brain is thinking about the joke. To change from engineers so McKenna can be happy. This is about a Scots guy who was absolutely crazy about golf. Now, this is true. I don't play golf. I've only got one good eye, no depth perception. Trying to hit that little ball is a exercise in frustration. Never was interested. But in Scotland, there's golf courses everywhere. They are really keen on golf. So this joke makes a lot of sense to many Scotsmen. Before I get into a joke, just something else to get to. In Scotland, they play golf in the snow, as long as it's not too deep. They use orange golf balls so you can see them. They'll play in the rain. They'll play in howling gales. I've even seen them when there's lightning out playing golf, right? And you think about it, you're holding a lump of metal. You're kind of asking for trouble. Nothing stops them. So that's the background. Two Scots guys were playing golf. One of them was that fanatic guy, and he's about to take his shot, right, about to putt the ball. And he notices at the end of the golf course a funeral procession driving by really slowly. So he stops and he takes off his cap, bows his head, and he lets the procession go by. And once it goes round the corner and it's out of sight, he puts his hat back on and he's about to take his shot. And his friend looks at him and says, you know, that was amazing. I know what kind of fanatical golfer you were. That was really nice of you to stop to let that funeral go by. And the guy looks at him and he says, yeah, he says, she was a good wife. McKenna, I didn't get much reaction from you. I think you want me to go back to engineer jokes.
That one was pretty good right there.
So, yeah. No? Ian, good joke? Couldn't hear it? Didn't get it?
I caught it.
Yeah, but it wasn't that funny. I'll
I
tell
was
you.
just slightly paying attention.
Okay. At least I've now got your attention because you're frightened I might tell another joke. So I'm not going to, so you're safe. what we are going to do is a quick look, hopefully a quick look, at the last of the questions on the homework so that we can then move on. Some of the questions that we just covered, can you see these A's cancelling and the A's and B's cancelling? Right, that's the basically, they're very quick. I mean, I'm just looking at this one randomly. Can you see in this question here, the 22 and the 42, you could divide both by 2, so that would be what, 21 on the top, 11 on the bottom. And won't the x's totally cancel out so there are no more x's in the answer? And won't there be a y left on the top? So if I was doing this one, if I click on this, do you see the little guy over here that you get? So I do the fraction button. On the top, I believe it was 21, and there's a y. And then, oops, that's a capital Y. And there's a y. And then on the bottom, I think all we got was 11. Everything else get killed off. And that would be my answer. So pretty quick, right? And now we get to the questions, they're very similar to what we've done here. So let's just talk through a few. Let's look at this one here, question 19. There's nothing you can do to the top. Is there anything you can do as far as factoring the bottom? Can you see anything on the bottom that we could use to factor this?
(6n).
I hear 6n. Can you get better than just n? I like the 6 and I like the n, but can you get 6n cubed? Could you get 6n to the power of 4? In fact, how far can you go before you can't do it anymore?
Five.
Yeah, so 6n to the 5 is what you should do to that one, and then it cancels. Right. On this question here, if you take a look at this question, you could take out a common factor of 7 from the top, and that would leave you 7x minus 2. Wouldn't do much, but you could. Do you know you can cancel the bottom and call it x minus 2 squared? So evidently, you're going to have, that's interesting. Let me pause on that. Yeah, I'm going to write that one down because saying it really doesn't help. And we've got our little trick that worked last time, so if you can bear with me just for a few more moments, with a bit of luck, we'll get it to work again. Ah, darn it in space. Don't do that. No, that's fine. Okay, I'm going to go back out and back in, and then I'm going to show you basically what's going on here. Right, so we have a fraction. This might take me longer than it's worth. Right, here we go. And on that fraction, the top is 7x minus 4. And on the bottom we have x squared minus 4x and some other stuff. So let's see what that looks like. I'm probably not going to do this. This is too slow. I'll start at this one, so I'm going to finish it. So we have an x squared. We have a take away 4x. And then we have us add 4. See if I can make this just a little bit bigger. Yeah. Now I know that I can factor the top, the numerator, and I know that I can factor the bottom. So that's what I'm going to do next. Can't you take out, oops, my apologies. No. Can't you take out a common factor of the number 7? And that's going to leave you with That guy. Great. What about x squared minus 4x plus 4? Well, that definitely factors as well. It's a trinomial. Since it's got an x squared here, it counts as what? A simple trinomial, so it's going to be x plus or minus a number, and the other bracket's going to have an x plus or minus a number. So I'm looking for two numbers that multiply together that give me 4, and those two numbers end up being negative 4x when you're finished. So that tells me that they're both negatives. And since I can only do 2 and 2 and 4 and 1, it doesn't take much for me to figure out that the correct combination is x minus 2, x minus 2. So, original question, factored. Final stage, cancel, 1 for 1. Guy on the top, this guy, isn't he going to get killed off just one of these guys? That's why I say 1 for 1. So I take that guy out. I take that guy out, and that gives us the one that goes there. So does that look very like the ones we did earlier today, right? You factor, you cancel, you see what's left. If you go to question 21, can you see it's going to be factor, cancel, and see what's left? They've kind of made your life a little bit easier, because since they give you a choice, you don't need to worry about, trying to type it in so it makes sense. Can't you just look at the choices and pick the right one? This one here is question 22, which I'm going to write down. And it's going to be the last one of this type, and then we're going to move on to multiplication and division. So if you can bear with me for just a few moments. 4d squared plus 21d add 5. And the reason I'm picking this one is because it is almost like the ultimate in ugly. So I'll cancel that off. We don't need to save that. And I'll cancel this because we don't need to do anything with that. And I'll stop sharing, and I'll come back in, and let's see what the heck this is going to look like. This is going to challenge you. I need to factor two really, really ugly trinomials. 4d squared, that makes them complex. If you're doing 4d squared, so I'll do my kind of working over here. This is me only focusing on the top. I'm not even worried about what's going on at the bottom. If you're doing 4d squared, isn't there actually two different possible combinations? Couldn't it be a 4d 1d split? Couldn't it be a 2d 2d split? Now I'm going to focus on the number plus 5. Because this says positive 5 and because this says positive 21, doesn't that at least mean that I know that whatever combination I use, it's two positive numbers that multiply together to give me 5. So that means I'm going to do a plus 5 and a plus 1. Or I'm going to switch places. So basically, trial and error says you try one, if it doesn't work, you try the next if it doesn't work. If you keep on going, you'll eventually get the one that does work. Once you find one that does work, you stop looking. Okay, let's look at this one first. Does this one work or not? Well, let's find out. If I did the FOIL part, and the only part of the FOIL I'm actually going to do is the O and the I part. Won't 4 times 1 get you 4d? And won't 5 times d get you another 5d? Wouldn't that add up to 9d so it doesn't work?
Super nice. They're super nice.
Right? Now, if you don't mind, I am going to mute you again. There, that's better.
I think that'd be a good idea.
Let's try that again. Go away. Yes. I'm quite sure they don't want us to hear the conversation. I've lost my place here. Back into the question. Right, here we go. So that one failed, right? So forget it, ain't going to happen. How about this one? Does that one make it? Does that one eventually get you 21D? Well, let's figure it out. Inside, outside. 4 and that gets you 20D. 1 times that gets you 1D. 21D, we have got it. So the top guy is 4D plus 1, D plus 5. Okay, let's focus now on the second one. 4D squared plus 21D. Yeah. Let's try that again. 4D squared plus 9D plus 2. And I have just realized something. Isn't that guy, this one, isn't that guy getting you 9D, and this one got me 9D. So I kind of got lucky there, because it's going to be 4D plus 5. Oh, no, it's not. I'm too busy scanning the wrong place. It's a different number now. It's not. It could be 4D plus somebody, but it's that combination. Or it might be that combination. Oh, I think I got lucky. Does that one work? Does that one get you 9D? Can you see it? You should be nodding because it does. So the top guy we got was this fella. The bottom guy we got was that fella. I'm a bit disappointed. I thought I would get... Oh, I wrote the wrong one down. That's there. I wondered why it didn't work. Now I'm not disappointed. Doesn't that guy cancel out that guy, which is what I was expecting to see. And now I'm left with our answer. Are we good? Right, so if I give you a rational expression, are you comfortable with factoring and cancelling, which is essentially what this technique is, right? You factor everything in the top, you factor everything in the bottom, and then you do a 1-for-1 cancel, and you make it look as pretty as you can. So what we're now going to do is look at multiplication and division. And the good news is, you don't need to learn much more. You've already got almost everything you need already. You've already done practice at it. So let me show you how that might work. And I'm going to go right into I'm going to jump right into the really ugly ones. I'm not even going to play about with it. Because if we can do the ugly ones, we can do the easy ones. Right, this fraction is going to get multiplied by this fraction. And we are expected to multiply and to then simplify the answer. So I'm not even sure this line is necessary, but I'm going to put it in anyway. When you multiply fractions together, you essentially just stick the tops together and you stick the bottoms together. So what you're looking at is just a single fraction now. So I've already done the multiplication. Technically, I have multiplied these two things together, right? This fraction times that fraction becomes this single fraction. And do you see, that's a pretty straightforward part. Now the tricky part. Every single term that's on the top gets factored. Every single term that's possible to do it to on the bottom gets factored. And then you can do the cancelling. So here goes. X squared minus 1 is a difference of 2 squares. Do you agree that's x plus 1, x take away 1? I don't think I've shown you this difference of 2 squares before, but it is one that you should have met sometime in your past. Do you know that counts as a difference of 2 squares? Two things, squaring going on and subtracted, typically are difference of 2 squares. But what you don't have, or what you have to take account of, is that it's not x squared anymore. So you don't get x plus 5, x minus 5. What you get is 2x plus 5 and 2x minus 5. You see, that's the only adjustment that you need to make. So on this side, I get 2x plus 5 times a 2x minus 5. So you factor everything in sight. In this particular question, can you see that there's nothing on the bottom that can factor? It's actually as good as it's ever going to be. So put them together, factor everything in sight. Now what's left? The cancelling part. And remember, it's a 1-for-1 cancel. So I'm going to cancel one of these for one of these and leave behind a little one. I'm going to cancel one of these for one of these and leave behind a little one. And let's see what's left. Well, on the bottom, there's only a 1. There's this term and this term left on the top. Now, am I finished, or can that be written a little bit nicer? I see nods, so you agree it can be written a little bit nicer. What would be a better way to write this fraction? If something's over a 1, is it really a fraction? Last chance?
Just take away the 1.
Thank you. Can you see that in some cases, it's happened before today, hasn't it? That you don't really end up with a fraction, you end up with just an expression that is no longer in fractional form. So the process that we did is step 1, combine the two terms. Step 2, factor. Step 3, cancel. It's got a nice 1, 2, 3 to it, isn't it? Put them together, factor everything in sight, cancel. And I guess sometimes there may be a step 4. You know, make it look pretty, right? If it happens. Would you agree that there's not an awful lot of extra process? Couldn't I have just gave you this ugly fraction and said simplify it? Wouldn't that really be the same question? All we're doing is saying, you start off as 2 single fractions being multiplied, but if I stick them together, I now have 1 fraction, and I use the same rules that we've been doing for the last half hour, you know, factor and cancel and make it look pretty. So that was a really ugly one, just to get you chucked in at the deep end. Let's look at a relatively easy one. And let's look at that ugly mess. So I'm going to take this ugly fraction and multiply it by this ugly fraction. And then when I'm finished, I'm going to try and simplify it. So let's see what the rules are this time. Now, you take this fella and you multiply it by this fella. Things change a little bit because of the format. Would you agree that the 2 times the 2 gets me a 4? What will an a cubed times another a give me? So a cubed times one more a. What will that give me? Agreed. I see your lips moving. Yes, a to the 4. Won't that b squared just be b squared? And won't that c just be a c? Are you happy about the 2 terms on the top when you multiply them together give you this? Okay, let's look at the bottom. 4, that's it. Alphabetical, a squared, b, and c. I think it's a good idea to do them alphabetical. It just makes it easier to match them. So I have done what we called step 1, right? I've multiplied them. I don't really have a step 2 here because these kind of questions don't need factoring because they're factored, right? But what they do have is a cancel, don't they? So let's see what happens with the cancels. Oh, a really nice one. Won't the 4s cancel out? What would an a to the 4 do on the top when you cancel it with an a squared on the bottom? What are you going to have left over in that situation here? A to the 4 top, a squared on the bottom.
On top.
I hear you. Together you gave me the right answer. A squared on top. Right, let's look at this fella. I'll do a little dotted one just to be different. A b squared on the top, cancelling a b on the bottom. What's going to be left over this time? Right, and will it be on the top or on the bottom? There's a b
Top.
left over. Yes. I want the c's just cancel, so I guess I'll leave 1 behind. Let's see what I've got left. 1 a squared b and 1, which really just gives you a squared b. And 1 and 1 and 1 and 1. Oh, I seem to be picking a lot of examples where you don't end up with a fraction. That's just sheer bad luck or coincidence. Are we comfortable with this process, how this is working? So far, so good? Let's go back to some quadratics then. How about x squared, take away 7x, subtract 8 over x squared plus x. Okay, that's a pretty major heavy duty one again, right? If I want to save a line of work in, couldn't I just ignore the bit where I stick them as a single fraction and just go straight into factoring everything? So let's see what we can do. For no particular reason, let's look at this guy here. X cubed plus x squared. If you want to factor that, isn't it a common factor? And the common factor is x squared. This fella here is a typical trinomial, and because it's got an x squared, it's one of the easier kind, the simple kind. Aren't I looking for 2 numbers then that multiply together that give me -8? And when I add those 2 numbers, I get -7. So I am looking for 1 positive number and 1 negative number that matches this situation. What are the 2 numbers that I should use to get that?
-8 and 1.
And check, it works. Let's look at x squared plus x. Not a lot going on there, but you can do something, can't you? What can you do about x squared plus x?
X times x plus 1.
So you take out a common factor of x, agree? Would you, oops, my apologies, that should have had a square there, I just realised it. Wouldn't x squared take away 2x plus 1? Can you trust me that that factors? And I'll just go in and I'll tell you that that's where it factors to. So can you see in this question, tons of things get factored, right? All over the place. But that's good. That gives us more opportunity to cancel things. Is there anybody on the top that you know you can cancel out with the same guy on the bottom?
X plus 1.
Right. And I'm going to cancel 1 for 1. And I'll leave behind a little baby 1. Is there anything left on the top that will cancel something on the bottom?
X squared and x.
Yes. So you see the x squared here on the x? So I'm going to cancel that, and would you agree that you're left with an x on the top? So what we got? We got this guy, we got this guy, we got this guy. I'd probably put the X first because it looks prettier. I got a 1 and a 1, and I got these two guys, so. At least it's not a, you know, an over 1. At least I didn't get that. Is there another way of writing that? Actually, I'm quite happy with that. Hopefully the software is. But is there any other way of dealing with this thing?
X minus 1 squared.
Now, it looks like the typical way that they do the questions is they'll have a little circle around them. So they're probably only going to give you that one or that one, so you'll know which one works. If it's none of the list, then you've either screwed up or you think the answer's this and they gave that, and you have to look at it and say, oh, wait a minute, my guy is this guy, and you put a dot on it, and that's how you get them. Okay, a lot to take in. I want to just get, I'm just going to batter on here. I'm going to do division, and then we can finish. And that, I think that's probably better, because if we try and do 3 hours and 40 minutes, I think we're already getting to that pace. Do you want a 5-minute break just to get your head cleared again, and then we'll come back and we'll do division, and once division's finished, we'll call it a night. All back, we're going to get started on our last thing. This is pretty much the last piece you need to get your homework done. We went pretty good. I got a feeling that for most part we got through it. I'm going to put online, probably tomorrow sometime, a package that I've put together in the past, and basically it's just going to have lots of examples of factoring. So if you feel a little bit rusty and you were getting caught out about, I know the process, but I'm going to come out, I might fall down on, I'm not always very good at factoring. I'll put this online. It'll be a PDF, and you can have a look at it, and it might refresh your memory and get you up to speed. Because for this process to work, a major part of it is being able to factor things, right? If you can't factor things, the question's really not going to go very far. So, division of rational expressions. Well, let's look at division from a very basic point of view. I know it's a long, long time ago, but do you know if you were going to divide two fractions, and fractions are just rational expressions, isn't there a weird rule that we say, look, just do it, it works? Doesn't a division turn into multiplication by reciprocal? Can you remember that? We just said, look, it works. Trust me, I'm a mathematician, it works. We're going to use that property to divide rational expressions. So, if it was x squared y cubed 4 over 6c cubed, and it was going to be divided by 2xy over c. Right? So imagine we're going to take this and divide it by that. We have one extra step. We turn it into a multiplication by reciprocal. Me personally, I like this line. You may choose not to use it.
You forgot the cubed above the y for the x squared y.
Thank you. 12xy c cubed. I find it helpful to take these and just put them together as a single package. Are you happy about the x squared and the y cubed and the c? But in the bottom it might be a little bit less obvious, but that's where the 12 came from, the x and the y, and then finally the c cubed. Well, it's ready to go, isn't it? Ready to cancel this guy with that guy kind of thing? Can I do any kind of cancelling with the 4 and the 12? Agreed? 4 and the 12, divide by 4. What are you going to get? What, a 1 left over and a 3 left over? That's that done. Can the x squared and the x cancel? Sure can. When they do cancel, isn't there an x left over? And this x belongs on the top, doesn't it? What about a y and a y? Do they cancel? Yeah.
It's the y cubed, isn't it?
Oh God, I forgot that again. Well
Just
done.
what I said.
Yeah. Well, I fixed it up here and didn't fix it later on. Go figure. You can tell why 3 hours and 40 minutes is not a good idea, right? So I'm getting to the point where I think I'm causing more damage than help. Can you cancel a y cubed on the top with a y in the bottom? Yes. What do you get left over?
Y squared.
And it goes on the top, doesn't it? And this is getting really messy here, but if you cancel the c and the c cubed, don't you get c squared left in the bottom and you're finished? Apart from that extra step of turning something upside down, isn't division pretty much the same process as multiply? In fact, isn't multiply pretty much the same process as simplify? So although they are grouped into 3 headings, simplify, multiply, and then finally divide, the skill set that you use to do one is pretty much the same skill set through all 3 processes. So let's up the ante a little bit. I was running out of plain paper, so I'm going to use some line paper now. And let's do a x squared take away 9 over a 2x plus 3 divided by a 2x take away 6 over 2x squared plus 7x plus 3. So I've kind of jumped from a relatively easy one into a real stinker. Now, you probably will not use anywhere near as many lines as I'm going to use. But if you like, I'm putting this down as, oops, there, see, I already screwed up. As a kind of putting in every step I can think of. So turn it upside down. Now I'm going to combine them. So I got this guy, and next door to him, I got the 7x with a 3. And on the bottom, I got these 2 guys. So a division gets turned into multiply by reciprocal. You then take everybody in the top and you put them together, and you take everybody in the bottom and you put them together. Now, I've deliberately not factored some of these terms. I could have factored them a lot earlier and it would have been totally fine, but I've decided to do it now. There is nothing else to do with these 2 terms. They are good to go. X squared minus 9. Do you, oh, well, let me just keep going. I've noticed something. X squared minus 9. Difference of 2 squares? X squared minus 9. Difference of 2 squares. How's that going to work out?
Positive and negative.
Okay. Great. Can you trust me on this one? But if you take the 2x squared fella, you get 2x and x, and you get a plus 1 and you get a plus 3, right? So far, so good. Now, I look at that expression and you might think, oh, that's just one of those annoying expressions where nothing cancels. But I did notice something that I should have noticed earlier. Is that 2x minus 6 factored as much as it could be?
No, you could factor.
No. I could have factored out a 2 and shouldn't have done that, and I forgot to. So I'm going to do it now. If you factor out a 2, this guy becomes x take away 3. And that's kind of helpful, because don't we at least get one cancel out of the whole question? And so I'm left with an x plus 3, another x plus 3, a 2x plus 1, and on the bottom, 2 lots of 2x plus 3. I'm quite happy with that answer, but if you get choices and it's not there, won't they probably combine them and call it x plus 3 squared? And that's what it would look like. Any questions about that? Are we getting the feel for division just becomes a multiplication, then you do what you always did? You factor the heck out of it, and hopefully you'd remember to factor the heck out of it, right? Totally. And then you should get cancelling almost in every situation. So let's give me a few moments and we'll go and have a look at what the homework questions look like, because they're, who knows, I may have forgotten something. Right, so are you looking at multiplying and dividing? Can you at least see that? Yeah, okay, I'm clicking on the view one. 17 questions. I'm going back out, and I'm going back in, so this time you should see it. Right. The first couple of things are really just what was the word I'm getting at? The first couple of things are just examples of what terms are. So you're going to be looking at numerators, factors, denominators, all those kind of terms. So that's what the first three are. Now, here's something interesting. Write this guy as a fraction. Do you know sometimes you can get a question, fraction divided by 4x plus 1? Can you imagine that as a question? Right? Fraction divided by 4x plus 1. So you have to know how to write down things that are not fractions as fractions. And there's a quick trick to this. Do you know if you stick a over 1, everything can be turned into a fraction? So you go over here and you do a little fraction thing, and on the top you type 5x squared. Oops. You can tell I'm getting tired here. 5x squared. There we go. Plus 32x. Oh dear. I am working on vapors right now. I told you what. Oh, wait a minute. I'm okay. Phew. That is correct, right? That is as a fraction. Now, what's the reciprocal of it? Well, don't you take this fraction and you do just one thing? Don't you turn it upside down? That's what reciprocal looks like. So that guy belongs in the bottom, and this guy goes in the top. So I didn't show you that, but pretty easy to do. That's how you tackle that one. Here, two guys being multiplied, so there is no division going on, right? Here, two guys getting multiplied. Here, two guys getting multiplied. They're all multiplying right now. Whoa. God, look at number 10. Oh, good luck. That is a stinker. Would you look at that? Oh, if you get that one right first time, you deserve money. That is a killer of a question. And now we're into divide. Right, so see if you took this guy and you want to divide it by that, don't you just turn this into b squared on the top and 48 a to the 8 on the bottom and then cancel away and you get some nice answer. In this case, won't you turn this fraction upside down, called its reciprocal, and then factor the heck out everything and it should cancel. That's interesting. I'm going to do 13. It looks weird, so I want to do it. And after I've done that one, I'm going to have a look at 15 because that is even worse looking. So you may not see what I'm writing, but I'm basically just writing down the questions here. Takes forever in a day. I'm almost done. Okay. Let's get out of this for a while. So there's a couple of really weird division situations that I didn't cover, you know, and you're never quite sure unless you go through every question what's going to be, you know, what's going to be on the menu. Right, this one I'm picking because it's weird looking. Do you know that y plus 6 can be written as y plus 6 over 1? So now it's a fraction. Do you know this fella can be turned upside down? And now I have a multiplication. I can't do anything with that guy, and I'm pretty sure I can't do anything with that guy. I can do something with this fella. Would you agree that y squared plus 12y plus 36 does factor? And I am going to write down an answer really quickly. How did I know that at least one of those two guys, in this case it happens to be both, but how did I know that one of these two guys was probably going to be y plus 6? There's a kind of clue. Can you see the clue is that the top has a y plus 6? So I'm assuming that the question has some kind of cancelling in it. Most of them should, right? So that's why I went this way. That means I can cancel 1 for 1. And we are left with our final answer. So it wasn't that long, right? It was a pretty nice question. This question here, I can promise you, if I give that to my Calc 3 students, half of them won't even attempt it. That's how hard this one is. So I'm going to show you it. And don't worry, I would never, ever, ever give you that question in a test, right? This is like a big challenge question, right? It's not a fair question to expect you to do, but it is kind of fun. So I do want to do it. So I'm going to write down only one term, this term here. I guess I really should pause a minute before I commit myself to doing anything. And turn this guy into a multiplication. Okay, top guy, 2p squared, take away 13pq minus 7q squared. I am going to have to factor 4 of the ugliest looking things you're probably ever going to deal with. Not just one ugly one, that wasn't enough. Every single one of them is just probably as ugly as the other 3. So let's look at this fella. This is probably the first time that many of you have ever seen a quadratic, or sometimes called a trinomial, where there are 2 variables, p's and q's. You see that? Have any of you ever seen a question like that before in your math, your 94, for instance? No. So this is new territory. So I'm going to show you a trick. Whenever you come across one of these questions, pretend q is equal to 1. So this is a little shortcut. Now, if you pretend q equals 1, you get 2p squared times 13p, take away 7. Do you see that the question now just becomes a normal, ugly quadratic? And then you factor it the way you always would. 2p and p. Now, I'm looking for combinations of -7. Can I save some time and say -7 and +1 is the one that works? Can you trust me that that's the one that works? Well, you might think, great, I've got the answer to a question I don't want the answer to. I want the answer to this guy, and you've gave me the answer to this one. But here's the trick. That 1 is 1q, and that -7 is 7q. You've now factored. So do you see how you turned it into an easier question, you solve the easier question, and you use its answer to get the answer to the original? Sneaky, but cool. So this top guy is 2p plus q, followed by a p take away a 7q. So that's that one done. Okay, next one on the list. 2p squared plus 13pq take away 7q squared. It's very similar to this one, except it has a plus here, right? So make q equal 1, and you now have 2p squared, 13p, take away 7. Okay, what combination of -7 do you think is going to get me plus 13 this time? What number goes here and what number goes here? Right, I want -7. Ignore that, that's a distraction.
-1 first and then 7.
Agreed. Now, doesn't that then become, see the little sneaky trick again? So what do we have? Well, next door to it, we now have this fella times this fella. So if you ever meet any of my Calc 3, you could say, hey, try this one, because I can do it. Okay, flip over. I have a p squared, take away a 48. Is that 48? That's not 48. That is not 48. Let me check that. I think I wrote the wrong number down. There we go, it's 49. That makes much more sense. Now, if you make q equals 1, won't this become p squared take away 49? Oh, you can't say that, can you? Sorry. If you take p squared minus 49q squared, if you make q equals 1, I'm using the same trick as before, doesn't it just become p squared take away 49? Do you recognize that as another difference of two squares? Agreed? And that becomes 7q minus 7q. So on the bottom, p plus 7q, p take away 7q. Okay, only one last piece and we can call this guy done for today. Don't I need to factor this guy? Okay, let's see if we've picked up my little shortcut. If you make q equals 1, what will I now write that down as? I'll start it. 2p squared. What goes next?
$5p.
Okay. And? You might have said it, but I didn't hear you.
2 squared.
Well, if q is 1, isn't 1 squared just 1? You basically ignore the q, right? Isn't it a bit, when you make q equals 1, isn't it a bit like going to the thing and just rubbing out, erasing the q's? Right, if you make q equals 1, that's kind of what it's like. Now, I know how to factor this. It's going to be a 2p and a p. I'm looking for combinations of 2, not that there are many, right? It's 1 and 2 or 2 and 1. I believe it's 1 and 2. And then don't forget to give your q's back. So what we now have is 2p plus q and p plus 2q. Now, I hope after all this hard work that we at least get some cancelling, right? So I'll take this away because it's a distraction. Can you see anything in the top that's exactly the same as the guy in the bottom, and therefore I can do a 1-for-1 cancel?
P minus 7q.
Okay, so that one with that one. Okay, leave a little one behind. Is there anything else out here that something that's here can cancel with something else that's here?
2p plus q.
So this 2p plus q will cancel out with this one, agreed? Have we got anything else?
P plus 7q.
That hard work's been kind of worth it, hasn't it? Because we got a lot of damage done. In fact, as far as I can tell, isn't that the only guy that's left on the top? And there's only one guy in the bottom. And that's the end of that question.